previously we talked about the real meaning of definite integrals, that is like looking at the area under graph from the certain x value to another x value. Now, how did we actually get to there is by calculating the sum of the rectangles that is under the curve. Okay, so to get the area under curve is actually looking for the sum of rectangles that is under the curve. And to put it in more precise, okay, we are actually making it into many small strips such that like n becomes infinity. I will talk about that later on. Okay, so for example, in this case, I want to find the area under curve from 0 to 1. I'm going to divide this part from 0 to 1, right, into n strips, okay, where n, it could be 4, it could be 100, it could be 1 million strips, you know. So if I divide it into n strips, right, so I have 1 over n for one part of the rectangle. So the breadth is 1 over n. Now if this is 1 over n, the x value of this is 1 over n plus 1 over n. That's 2 over n. And the next guy, okay, by observing, it will be 3 over n, 4 over n, and so on and so forth. And the last one, which is 1, is actually called n over n. Okay, so to find the area of the rectangles, I must use breadth times height. The breadth of the rectangle will always be 1 over n. Now what is this height? The x coordinate, right, is 1 over n. The y coordinate, so look here, this is y equals to 1 over 1 plus x. So this will be 1 over 1 plus 1 over n. This is the y value. Label the corner of the rectangle in the coordinates, in coordinates form. Okay, so this guy will be 2 over n, comma, 1 over 1 plus 2 over n. Yeah, that's the y coordinate. So the second corner, yeah, this is like a guided exercise, is over 1 over 1 plus 2 over n. Okay, so by inference, the third corner will be 3 over n, comma, sorry, this is 2 over n, yeah. Okay, 1 over 1 plus 3 over n. And the last corner will be 1, which is n, okay, comma, 1 over 1 plus n over n. N over n is 1. Okay, so it's all about, okay, inferring and be able to see this. Okay, so I want to find the area under curve. That will be the sum of the rectangles. So I'm just going to write down, oh, the sum of the rectangles is going to be, now what is the first rectangle? The first rectangle is the breadth, 1 over n, times the height, 1 over 1 plus 1 over n. That's the x value and that's the y value. Plus, the breadth will always be 1 over n, but the height will be different. So you look at the second one, the height is shorter, right? And what is the height? It will follow the y value, 1 plus 2 over n, plus so on and so forth until the last term, which is still 1 over n times 1 over 1 plus n over n. Okay, I realized that 1 over n are all the same. All the breadths are 1 over n, so I took out a 1 over n. And then I make a common denominator, so this is n plus 1 over n, plus 1 over n plus 2 over n, plus dot 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 until the last term, n plus n over n. Okay, a reciprocal of this, I'm just going to bring up the n, so this is n over n plus 1 plus n over n plus 2 plus n over so on and so forth. There will be a n plus 3 here, plus dot dot dot, n over n plus n. Okay, they want you to express this in the form of a summation. So you factorize all the n from the numerator out, right? Okay, you can cancel with the 1 on the outside. You are just going to be left with 1 over n plus 1 plus 1 over n plus 2 plus dot 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 plus until 1 over n plus n. So you can see that these numbers here, this starts from 1, 2, all the way to n. We can put them into a summation sign where if I change the formula to 1 over n plus r, my r starts with 1. And what is the last term of the r? It is n. Okay? And then the general formula will be 1 over n plus r, where r is the guy that keep on increasing, as you can see from the previous step. And this is how you can get the summation that they want. Okay, so now we have established that already. Part 2 is telling you, illustrate that the area tends to a limit. So if I only cut this into a certain strip, there will be many empty spaces that is down here, right or not? Yeah. But if I make it the strip so small, like maybe 1 million strips over here, then the strips will actually kind of like cover all the areas that is going to have empty spaces. And what is the question asking you? The area tends to the limit is, that means the first part that we found is the summation of r equals to 1 to n, 1 over n plus r is actually equals to the sum of the rectangles. Okay, so I already put it down here. The question is actually looking for that if you have n strips and the n is so small, so big, like 1 million, this means that n tends to infinity. And when we do this, we have to say, now how do we change this into a limit form? Or the limit as n approach to infinity. Okay, the summation of r equals to, okay, or n plus r is going to be equals to, yeah, correct, n, r equals to 1 over n plus r. So I don't know whether it converges or not. Okay, so I'm going to put this into a calculator. I already show you the steps. Okay, instead of having r, I put it as x. Sorry, having n, I put it as x. Okay, and how to get r in your GC? Okay, look over here. It would be, now you can go to the y equals to, you can go to the plotting function. Okay, if you do not know that the summation is alpha y function, can you see summation number 2? This is the summation sign. For r is alpha multiply, r is in green, alpha multiply, r starts with 1 all the way to n, n is x. Key in the expression that you want, 1 over n plus r, which means it's x plus alpha multiply, okay, x plus r. Then, before you start, I want it to go to infinity. Give me a number that we can see the behavior looks like infinity. It could be 1,000, it could be 5,000, okay? But if you put 1,000, and I'm going to put second function table, it will load for a while, so you have to wait for this to finish loading. Okay? So once it finishes loading, you will be able to see that when it goes to very high, it will tend to 0.6929. So in a way, this is also a form of showing how does a series converges. Okay, and then all you can say that this is equals to this should be here, 0.69. Okay, when there are infinity strips of the triangle, the area will be 0.69 square units. Okay, this is what the question. This is the whole reason behind area under graph. It's actually dividing the area into very small little strips. Okay, so let's find it. Let's verify it with integration. The integral of 1 to 0, this should be an easy integration for you, is ln modulus 1 plus x with a definite integral of 0 to 1. That will be ln 2 minus ln 1, and okay, so that will be square units. All right. Let's verify this. Actually, almost every question in your H2 math, you can verify it with a calculator. Okay, math 9, you are going to integrate from 0 to 1, 1 over 1 plus x. So this is 1 alpha y, 1 plus x, and dx. And you will realize that they will give you 0.693. Okay, so which is actually very close to that, 0.692. All right. Okay. So area under graph is actually finding the strips, okay, of the rectangle that is under the curve. Let me just do a small recap for you. In order to make it into a summation question, label the corner of the rectangle with the x and the y. How to get this y value? Sub the y into the equation. Okay. Label the x into the y. Okay, and then just use the breadth will always be 1 over n. The height will always be the y value. 1 over n times the first y plus 1 over n times the second y, so on and so forth. Make it nice. Look for the one that keeps on increasing, and that would be your r, and then you can put it into a summation kind. Okay, when the question asks for a limit or asks for the convergence, all you need to do is to put this into your calculator and then change the table start to 1000, use second function table to see whether it converges to a certain value or not. And the last part would be to verify it with integration. Usually the question will ask for it. Okay, to verify that whose approximation is better, okay, and things like that. But that depends on what the question is asking, but this is how you find, okay, area under curve using the sum of rectangles.